A rectangle floor measures 24 by 32 feet. Find the length of the diagonal of the floor. Well, if you see the diagonal, it looks like the hypotenuse of a right triangle. Let's see if we can set up 24 squared plus 32 squared equals c squared. And I get 24 squared is 576. 32 squared is 1024. If I add that together, I get 1600 square root, so I get C has to be 40 feet. For number 34, we're going to, the cost to manufacture X units of a product is given by the function C of X is equal to X squared minus 10X plus 3000. Find the number of units manufactured at the cost of 8,600. Well, if the cost is 8,600, that's our cost, so I'm going to put it in for C of X. And solve, we need one side to equal 0. So I'm going to have 0 equals X squared minus 10X minus 5,600. We're going to factor this into X minus 80 and X plus 70. Setting each of those equal to 0, I get 80 and negative 70. Is it possible to manufacture negative 70 of something? No. So we will eliminate that answer. And we get 80 units. For number 35, we're going to factor and set it equal to 0. I know the factors of 12 that add up to 8 are x plus 6 and x plus 2. Setting each of those equal to 0, I get a set of zeros at negative 6 and negative 2. For number 36, we're going to move this to the other side. I'm going to get 2x squared plus 10x plus 2 equals 0. And the first thing that we should do is factor out a 2 out of everything. Anytime we factor, that's the first thing we should look for. And I notice that this is not factorable, so I'm going to put it into the quadratic formula, and I get x equals negative 5 plus or minus the square root. 25 is 5 squared minus 4 times 1 times 1 all over 2 times 1. Simplifying that, I get negative 5 plus or minus 25 minus 4 is the square root of 21 over 2. Since our answer has a radical in it, I'm going to leave it as that as my answer. So negative 5 plus or minus the square root of 21 over 2. For number 37, again we're going to need to plug it into the quadratic formula because I don't know what factors of 50 add up to 10. So I'm going to go x equals negative 10 plus or minus the square root. 10 squared minus 4 times 1 times 50 all over 2 times 1. Simplifying, I get negative 10 plus or minus 100 minus 200 gives me the square root of a negative 100 over 2. This would be a good time to remind you that this is an imaginary answer, and these roots would not go through the x-axis. We can simplify our imaginary answer, our complex answer, because there's a whole number part of it, to negative 5 plus or minus 5i. For number 38, we're to sketch a graph of the quadratic function, give the vertex and the axis of symmetry. Well, our vertex is at the opposite of this number, same as this number. So my vertex is at 4, negative 3, which puts it there. We know it opens down because of the negative, and it's going to be narrow because of the 4. We're going to find the axis of symmetry at x equals 4, the x value of the vertex. Let's see if we can find another point or two to see what the shape would look like. Let's plug in a negative, or let's plug in 3. 3 minus 4 is negative 1. Negative 1 squared is 1. 1 times negative 4 is negative 4. Minus 3 is negative 7. So if we go over 1, we go down 4. Because of symmetry, we know the same thing's going to happen on the other side, and we're going to get a shape that looks like that. For 39, we're doing the same thing. Opposite of the 2 would give me negative 2, same as the one outside. My vertex is at negative 2, 1. We know that it's going to open down because of the negative. It's going to be wide because of the 1/5. If we want to find another point, we could probably make our table and plug in negative 1. If I put in negative 1 plus 2 gives me 1. 1 squared is 1. 1 times negative 5th gives me negative 1/5. Plus 1 gives me positive 4/5. Let's put in a 0. 0 plus 2 is 2. 2 squared is 4. 4 times negative 1/5 is negative 4/5. Negative 4/5 plus 1 is positive 1/5. So I get, and it's going to be symmetric on the other side, we know that it's going to be very wide and open down. Question number 40. We're going to give the vertex y-intercepts, x-intercepts. First thing we're going to do is put it into vertex form by completing the square. We're going to subtract the 9 from both sides, giving us x squared minus 6x. Half of my b squared would give me plus 9 on this side, plus 9 on that side, and so I get h of x is equal to x minus 3 quantity squared. So my vertex is at 3, 0. My y-intercept is at 9, because that's when x is equal to 0, I get 9. And my x-intercepts, because my vertex is the x-intercept, it's going to be the same. So I know if I'm over 1, 2, 3 over, I'm at 9. 1, 2, 3 over, I'll be at 9. Graph that, and there we go.